is Sabrina from Mechanical Engineering, and I shall be presenting the introduction and problem statement. Malaysia benefits from advanced technological resources that ensures its populace has access to clean and safe water for their daily needs. However, certain regions, particularly rural areas, they face challenges in obtaining clean water. Our project aims to address this disparity by providing a solution that not only caters to those in need but also optimizes water consumption for those with existing access. As a tropical country, Malaysia receives a substantial average rainfall of approximately 3,085 millimeters per year. However, utilizing untreated rainwater poses significant health risks due to potential contamination. Our project centers on harnessing rainwater through a meticulously designed filtration system, rendering it safe for domestic use. As for the problem statement, firstly, we have uneven water distribution and urbanization straining Malaysia's water resource, where the rapid pace of urbanization and uneven distribution of water resources in Malaysia pose significant challenges to the nation's water supply. On the other hand, aging infrastructure and inefficient management also poses a problem to water scarcity. Malaysia's water infrastructure in some areas has aged considerably, leading to water leakage and wastage. Last but not least, water shortages persist due to limited access, and with a growing population, Malaysia faces the challenge of meeting the demand for water. So, by implementing our innovative approach, we aspire to improve the quality of life for those deprived of clean water, while also promoting sustainability and cost-effectiveness for those with access.
I'm going to talk about the most important aspect of this project, on why we choose rainwater harvesting system with built-in filter as our project. In the first place, we want to provide clean and accessible water to consumers without relying on other sources. And furthermore, we desire to save money on water consumption and enhance energy efficiency. Finally, we believe that our project will benefit people who do not have access to water from any other sources. For the next part, which is the design thinking application, I am going to talk about the platform and also the storage tank. First of all is the platform. We made the platform in order to increase the elevation of the storage tank so that the consumers can collect the water easier, since the pipe is at the bottom of the storage tank. We made it not too high to make it more stable and make the center of gravity as low as we can. Secondly is the storage tank. The storage tank contains 4 main components, which is the water level sensor, pipe for the outflow, inflow for the treated water from the filters, and also the overflow.
My name is Tani Sukumaran and I am from the Mechanical Engineering Department. So, I'll be presenting on behalf of the design thinking concept of our group project. So as you can see, there is a funnel where it collects the rainwater to be flowed to the water filter and then to the storage tank. The material used for the funnel is plastic, where the above diameter of the funnel is 14.3 cm and the below diameter of the funnel is 1.3 cm. So the funnel is connected to the filter, where this is the filter. So the filter is designed in a cube because when we place it on top of each other, it is more stable. There is a hole of diameter of 0.2 above and below the filter for the pipes. The material used for the filter is perspex. The filter collects the rainwater that flows from the funnel and it filters it to become drinking water. As you can see from the poster, there is 3 different filters connected to each other with a pipe height of 5 cm and a diameter of 0.2 cm between each filter. So the rainwater flows through every filter and then finally to the storage tank.
Okay, hello everyone, my name is Aman Kaitir and I will explain the methodology of our project. So starting with rainwater collection, the rainwater is collected from the roof of houses through the gutter. So the rainwater will fall onto the roof and flow through the gutter. At the end of the gutter, a wire gauze will be installed to prevent large molecules from entering the filter that can cause damage. So the water will go to a three column of filtration. The first column being cotton wool, the second one is activated carbon, and the last one is cotton wool again. So the main filtration goes to the activated carbon, where the activated carbon will absorb all of the contaminants inside the rainwater. Then the rainwater will flow into the storage. So the storage tank features a water level sensor. It will indicate the percentage of water inside the storage tank from 35 to 50% to 75% until 10%. The water tank also features a overflow, which means the water will flow out of the storage tank to prevent overflow inside the storage tank. Lastly, to the consumer, so the consumer can directly take the water from the storage tank to use in daily life. Thank you.
Hi, I'm Nur Aisha binti Aizlan from Chemical Engineering Department, and I will present about the results and discussion of our project. From our survey, most respondents agree that rainwater harvesting system makes significantly lower water bills and have long-term benefits. The importance of this project lies in the following aspects. The first one is sustainable water source. Rainwater is an abundant and full resource that can be used for various purposes. By capturing rainwater, we reduce our reliance on conventional sources like groundwater or municipal water supplies. Rainwater harvesting systems also help people in areas where access to reliable water sources may be limited or during times of water scarcity. The second one is cost savings. Utilizing rainwater leads to substantial cost savings on water bills. By collecting and filtering rainwater on site, we can reduce the need to purchase water from external sources. Next is water quality. The built-in water filter ensures that the harvested rainwater is treated and purified by removing impurities and potential contaminants. The concept of this project revolves around a three-step process. First, collecting stage, in which rainwater is gathered from rooftops or other surfaces and directed into a storage tank or reservoir for later use. Next is filtration. The collected rainwater passes through a built-in water filter to remove larger particles. This stage helps to ensure the water quality and prevent clogging of downstream components. Our prototype employs activated carbon, which is known for its excellent absorption capacity and ability to balance the pH of water. Lastly, storage. After filtration, the treated rainwater is stored in a tank or reservoir for future use. In addition to the existing concept, we are incorporating a water level sensor to monitor the water stored in the storage tank.
Hi, my name is Ami Kusari bin Rasid. I am from Electrical and Electronic Engineering. I will present the project planning for our product. So for the first 2 and 3 weeks, we identifying the problem and brainstorming the idea, and then at the week 4 we start collecting the data from our survey, and then at week 4 until week 6 we are working on the extended proposal, and then at week 8 until week 10 we are designing and fabricating the prototype, and then at week 10 until week 11 we are working on the e-poster and video, and then lastly at week 10 until week 12 we are working on the final report. And about the economical consideration, so this is the overall our items are used in this project. So as we can see on this list, it is a little bit change from our planning because of the suitability of our project. So the overall of expense for our product amount of 80 ringgit and 20 cents, and there were no operation costs involved since we handled the entire process ourselves. And then our project present the most practical option due to its affordable price, and obtaining the necessary items for our project is easy.
As a conclusion, a successful rainwater harvesting system has been developed, featuring a built-in water filter and water level sensor. This innovative system aligns with the 7th and 9th United Nations Sustainable Development Goals, providing a sustainable water supply by utilizing rainwater as a valuable water source. By harnessing rainwater, this solution not only ensures access to clean water, particularly in rural areas facing disparities, but also contributes to significant cost savings in water bills. Moreover, the implementation of the system promotes water conservation, making it an environmentally responsible and impactful approach to address water scarcity challenges. A few recommendations that can be made includes using a more durable water filter casing such as fiberglass for better longevity. Other than that, we can incorporate more stages into our filtration system and also add smart connectivity which allows remote monitoring and control to collect real-time data on various parameters such as water level, water quality, and system performance through a web or mobile device. That concludes the end of presentation for Group 6. Thank you.